Hello, I welcome you all. The problem reads, determine the force in members CD, HI, and CJ of the truss and state if the members are in tension or compression. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have a truss here, and we've been asked to find the force in member CD, okay, right, here, as well as HI, as well as CJ. Where is CJ? This one there. Okay. So which one would be the best method of working out this? Of course, the method of sectioning would be okay. Right. So for this member here, CD, how do you think we're going to do it? Of course, the best is just sectioning here, right? So if you did the sectioning here, which part do we use? The left hand side or the right hand side? Which one do we use? What do you think? Of course, the left hand side, right? So that we take moments about H. Okay, is that fine? It's fine. If we took moments about H and we use the left hand section, then we are going to find the force in CD. Great. So this is the first case, right? What about the second case? The second case, we are looking at member HI. Which one is HI? This one here. The sectioning where? Okay, it's the same point here, right? And we have what? We have the left section and the right section. Which one do we use here? Which one do you use? What do you think? The right section. The right section. Where do we take moments? Which point? Joint C, we take moments about that point, but we use the right section and then we'll find HI. Okay, great. Okay, and then the last but not the least, okay, we have CJ. CJ, where is CJ? Where are you, CJ? I'm here. Great. Okay, there we go. CJ is here. Right. So how do we take the section? What do you think? Of course, there are a lot of alternatives. Which one do you think would be fine? For me, I'll take this one, right? I don't know which one you take, but I'll take this section. I have the left hand side and the right hand side section. Great. But when we take this section, I always mention or say that when you are dealing with trusses, you need to isolate zero force members, right? So if I took this section, already, of course, in your mind, you're saying there are a lot of unknowns. We have a force in CI, okay, which is unknown, but HI, we've already calculated it. So at this point in time, we already know it. But what about IH, okay? BC, okay? Of course, we want JC, okay? So if we did our inspection, we realize that IC is a zero force member. You agree? IC. Remember, they say when three trusses make a joint, three truss members make a joint, and if two members are collinear, if they are in a straight line like so, okay, then a third member is always a zero force member, right? Remember that principle? So if you have a truss joint that is created by two truss members, okay, and then if two of the members are collinear, the third member is a zero force member, as long as there is a condition, as long as there is no force applied at that particular joint and there is no external support at that particular joint. So these conditions, either one of these conditions must be met, okay? You don't expect to have a force here, okay? And you don't want to have a support like so at this particular joint, okay? There shouldn't be any of this. So there shouldn't be either a force, there shouldn't be either a support, or there shouldn't be both of these conditions, force or a support. So when you look at joint I, we don't have any force applied, okay? We don't have, this is joint I, okay? We don't have any force applied. We don't have any support at I, and two members are collinear, IJ and IH, they are collinear, and the third member, which is IC, okay, therefore becomes a what? a zero force member, right? So because IC is a zero force member, it even makes the work easier. All right, so because of that case, then I would use the left hand side, and then if I was to take a section here, I would use the left hand side and then take moments about joint B, right? If you took moments about joint B, then I'll be able to find IC. IC is going to have two components, one in the horizontal and one in the vertical. Only in the horizontal one is the one that is going to give me the result, because in the vertical it will not have a moment, because it will be coming through the point where we are taking moment. It will become passing through point B. Okay, are we fine? Great. So these are the methods that I'm going to use quickly, so I'll do that with you. So since we are using left section, right section, I'm forced to find the support reactions. I need the support reactions, if you realize, because there are times when you're using the right section, there are times when you're using the left section. So I'll be forced now to do the what? To find the support reactions. Right, great. So let's do that. Again, when we look at that, when you look at this again, with the engineering mind, when you look at this, you realize that at suppose even when we have a hinge at K, but we are only going to have one reaction, and that reaction is going to be horizontal. It is going to be in this direction. Okay, it is going to be in this direction. Of course, we know already to say it's going to be pulling like this, right? Okay, why? Because we only have one member connected at this joint, and for trusses, the force is always along the longitudinal length of a truss, because truss members that are usually used are always straight. Okay, so you expect the force in kj to be along the length, okay, along the longitudinal length from J to K, and therefore the reaction at joint K will just be in the same direction but in the opposite direction, right? So at K, you're only going to have one support reaction, even when it is a hinge, okay? So this is also very vital to notice. You need to really notice that quickly when you are drawing or working out, so that you don't get confused. Because of course you would say, since this is a hinge, you are going to have two reactions like this, but this component will not be there, right? So I'll leave it out. So I have kx like so, and then I have here, I'm going to have two reactions because of this horizontal member. You've seen this AJ, because we are going to have a force in here, okay, an axial force in here in AJ. This will have components both in the vertical and in the horizontal, and therefore it is going to introduce a reaction at the support, which is going to be vertical, right? So here we are going to have two support reactions. Okay, great. So there we go. So let's do that. Let's do the work quickly. So I'm going to take moments about point A. So I'll say summation of moments about point A equal to 0. What do we have? About point A, okay, I have kx, which is going to give me a negative moment, okay, kx by 4, right? Okay, clockwise, okay. And then I have what else? I have these forces, the contributions, they also be negative. So I have 1,500 by 3 minus 1,500 by 6 minus 1,500 by 9 minus 1,500 by 12 and minus 1,500 by 1, 2, 3, 4, 5, 15. Okay, and then is equal to 0. Therefore, our kx is going to be equal to, grab your calculator and do the calculation. So there we go, 1,500 by 3, 1,500 by 6, 1,500 by 9, 1,500 by 12, and 1,500 by 15. Great. Divided by 4. And then we have a 16,875 pounds. All right. Yeah, I think I've not made any error. So I have 1,500. If I was to factor it, is 3 plus 6 plus 12 plus 15. 3 plus 6 plus 12 plus 15. Okay. All right. 6 plus 9 plus 12 plus 15. Great. By form 16875. Right. This is correct. So, and is in fact this one is negative, right? Because this is all negative, so this is negative. Okay. So sorry about that. So this one is 1 minus 16 minus 16,875 pounds. All right, because it's negative. So it means, what this means is we just have to change the sign. So we are just changing the sign. Here it's supposed to go like so. And this is what we expect, right? So this is 16,875 pounds. Great. So let's find the others. So say summation of forces in the y direction equal to 0, like so. So what we have ay, then minus 1500. How many are there? I'm just going to multiply since they are the same. 1 2 3 4 5 times 5, right, is equal to 0. And therefore my ay is going to be equal to 1500 by 5. So this is 7,500 pounds, right? So this ay is equal to 7,500 pounds. Okay, and ax, we already know it, right? Summation of forces in the x direction equal to 0. Okay, what we have uh I'll use this direction now that I've assumed here. Don't get confused, right? Okay, I'll use that direction there. If you wanted to, you could have used the first one, but then you need to replace in the minus, like so. You need to replace in this minus, but I'll use this direction here, okay, the way it is. So I'll just say minus kx, okay, plus ax equal to 0. Therefore my ax is going to be equal to kx, which is equal to just 16,875 pounds. Right. So my ax, of course, you expect it to be equal, right? So that there is equilibrium in that direction. 16,875. Okay, great. So having found this, then I can wrap this. Okay. So then we go to sectioning. All right. So let's do the sectioning. So we are sectioning here, like we said. We have the left hand side, we have the right hand side, and we are going to take moments. Since we are starting with CD, we are starting with CD, remember CD, and we'll take moments about this point, right? No, sorry, we are taking moments about this point, okay, and we are using the left hand side, right? Great. Right. So if that is the case, so it means I don't want to redraw it because it's going to take some time. So I want to assume here we're going to have some I'm assuming here I have CDs like so, and then let me assume here it's like so. Okay, I'm using the left hand side, so I'll take moments about H. All right. So imagine I've done the sectioning there, then I want to take moments. So I'm using the left hand section. All right, let's do the calculations. Summation of moments about point O. All right. About point H. Okay. So, all right. Take moments about that point. So we expect to have 1,500 by 3 plus 1,500 by 6 plus minus 7,500 by 9, and then plus 16,875 by 4. This one will be anti-clockwise, then the rest will be clockwise. Okay, and then plus CD we are assuming is in compression by 4 equal to 0. Therefore CD is equal to, as our CD, did we assume the direction correctly? Okay, 1500 by 3, 1500 by 6, and then 7500 by 9, and then 16.8 by 4, and then CD, this is clockwise, right? CD is taking clockwise. This is clockwise, and clockwise is negative. All right, so CD 1500 by 3 plus 1500 by 6 minus 7500 by 9 plus 16,875 by 4. Okay, and then divided by 4. So this one is 3375 pounds. Okay, and it is in compression. Great. So there we go. I think we are fine. So now let's find IJ. We'll leave it the way it is. Let's find IJ. The only thing that will change. So let me just write there. HI, not IJ, HI. So just change the point of taking the moments. So it will be at this point. All right, we'll use the same section. Okay, so we are taking moments about point C, and right, taking moments about point C, and we are using which section are we using here? We've cut it like so. Okay, if we use this section on IJ, all right, so we are going to use the right hand section. We're using the right hand section, right? So saying summation of moments about point C equal to 0. There we go. Okay, so what do we have? We have a minus 1500, this one here, by 3, minus 1500 by 6, minus 1500 by 3, and we have minus I. We are assuming I is coming out like so, because we had assumed to be in tension, so it's coming out like this. Okay, it's coming out from the joint. Okay, we had assumed it to be in tension initially, so that's the same thing. All right, so I is in tension, so we expect it to rotate this in the anti-clockwise, so this is going to be plus HI by 4, and is equal to 0. Therefore, our HI is equal to 1500 by 3 plus This one is supposed to be 9. Sorry, why did I put 3 here? It's 1000 by 9, right? This one at the furthest end because they're taking moments about that point. All right. So 3 plus 6 plus 9, then divided by 4. So we have 6,750, and this one is pounds, and it's in tension. Okay, so let's look at now CJ. Okay, so how are we going to section this? CJ. CJ, we said we are going to section it like so. All right, and then which section are we going to use? We are going to use the left hand side. We'll use the left hand side. All right, and we'll take moments about this point. Okay, about point B. So let's assume the direction of forces. Of course, here at B, I expect a compression like so. Okay, let's assume here we have a tension in this direction. Okay, and then since IC is 0, remember IC is a 0 force member, so we only have a force in JIH, and we already know what this force is, and this in tension here, this force here. Okay, so let's take moments about point B. So we are going to have components from JC or CJ. We'll have a component like this here. Okay, this slope, we already know what this slope is. We have a 3 at the bottom, we have a 4 there, then the hypotenuse is supposed to be a 5. Okay, the hypotenuse is supposed to be a 5 because 4 squared, 3 squared is 25, root of 25 is 5. So 4, 3, then 5 there. So this component here of say CJ, this one here, this is sorry, this is CJ, this is J by 3 over 5, and then we are going to have another component here, and then this one is CJ by 4 divided by 5. All right, so with that information, let's take moments about point B using the left hand section. Okay, IC is 0, so we said the force in IC is equal to 0 pounds. This you should remember. Okay, so summation of moments about point B is equal to 0. Okay, let's do that. So what we have, we have a negative CJ is going in clockwise 3 over 5 by the lever arm, which is 4. Okay, what else? We have another negative from IH. Remember IH or HI? Okay, times also 4. And what else? We have another negative 7,500 by 3. Okay, and then we have plus 16,875 by 4. These are the only forces, right? Okay, The 16,875 is kx. Okay, ax is not going to cause a moment. All right. So we already know what ah is, so we just replace it there. Therefore, our cj is going to be equal to, let's grab your calculator. So we have 6,700, we have minus 6,715 times 4 minus 7,500 times 3 plus 6,875 by 4. We have that, and then we'll just divide this by 3/5 and a 4 there. Okay, yeah. So what we find is 7,500 pounds, and then we had assumed this CJ or JC to be in tension, and it has come out to be that way. Great. So I guess we are done, and I hope so let me just circle these solutions. So we have CD here. Let me use red. We have CD there. Okay, we have HI there. Okay, and we have CJ there. All right, so I guess we are done, and I hope the video was helpful. If it was, give me a thumbs up, like my video, share my video, and continue subscribing. Bye bye, and see you in my next screencast.